Do you know that in a smartphones there are billions of transistors? And do you know how the process to create a transistor? In this presentation, I will present on the fabrication of germanium MP junction using co-implantation and two-step rapid thermal annealing. First, let me introduce you with the foundation of transistor, which is semiconductor. In this experiment, I will use N-type semiconductor. N-type semiconductor is the semiconductor substrate, such as silicon and germanium, that dope with another ion. The group 5 of periodic table was chosen because they have 5 valence electron. So when the bond formed, a free electron was produced. For example, here we have the germanium blue as the substrate and phosphorus green as dopant. The covalent bond formed between germanium and phosphorus produce a free electron. Then, how we introduce the dopant ion to the substrate? In this experiment, we use ion implantation, which is co-implantation method. The reason we use co-implantation method for stress-induced activation, we shoot the two different size of ion, which is phosphorus and tin, into the germanium substrate. The phosphorus green is the dopant atom. Germanium blue is the substrate and tin yellow is the non-dopant atom. But the co-implantation technique will cause damage to the surface layer of germanium. The problem statement of this project is N MOSFET having quick diffusion restricted solid solubility from N-type dopants. When high density N-type dopant impurities are implanted, they cause severe damage and fault to germanium. The objective of this project is to introduce two-step rapid thermal annealing technique that consists of low temperature SPE followed by high temperature annealing for the dopant activation. Then, to observe the effect of two-step RTA towards the activation level from electrical characteristic using Hall effect measurement. Lastly, the finding from this project will be referred with the result from morphological characteristic project to observe the dependency of dopant activation to surface morphology. What we do with this equipment? This equipment is for rapid thermal annealing. As its name, it can ramp up to the high temperature in a short time. The maximum ramp up rate for this equipment is 50 degrees Celsius per second. Rapid thermal annealing used for the thermal process of semiconductor. With this equipment, we do a three different parameter, which is SPE only, SPE plus activation, and activation only. Sample with one step annealing also prepared for comparison. After SPE process, the amorphous layer of implanted germanium is regrowth into the crystalline layer. Next, after finish the SPE and activation, we must measure the carrier concentration in the substrate. To measure this carrier concentration, we need to use Hall effect measurement analysis. With Hall effect analysis, we can obtain the IV graph and the sheet resistance of the germanium. In conclusion, the germanium substrate that have been through ion implantation process using co-implantation method where phosphorus and tin were used as the two types of ion with distinct size were used as the substrate. To regrowth the amorphous layer and achieve high activation of dopant atoms in germanium substrate, two-step rapid thermal annealing was proposed. The electrical characterization will be done using Hall effect measurement analysis. The finding from this project will be referred with the result from morphological characterization project to observe the dependency of dopant activation to the surface morphology. That's all from me. Thank you.